Alright, this is going to be a continuation of anti-derivatives of inverse trig. Before I do 16 and 17, I want to do 18 and 19 first because they are a lot of fun. Notice how the only difference is your exponents for 18 and 19, and that's going to change essentially the whole thing. Um, Both of them kind of looks like inverse trig or U sub, and you just got to pick whether it's inverse trig or U sub. Now, if it's inverse trig, like number 18, your a is going to be 1, and your u is going to be x squared, which means that du is 2x dx, which works because then that's going to cancel out with the numerator here. Now, if I simplify this, I'm going to get 1/2 the integral of 1 over a squared plus u squared du. We know that is going to be inverse tangent. A is going to be 1. And then remember that's going to be u over a. So that's just going to be 1/2 inverse tangent of x squared over 1 plus c, and just call it a day. Now for 19, because you have a numerator of x cubed, I can't really do inverse trig here, so I'm just going to have to use traditional u sub. The x cubed is going to cancel out, but I'm left with a 4, a 1/4 technically, on the outside. And then remember that the antiderivative of whenever u is ln of u, going to replace that to be 1 plus x to the 4th plus c. The reason why I dropped the absolute value, once again, is because x to the 4th plus 1 is always positive, so you don't need to worry about the absolute value bars. Okay, so that was just a good problem, because you'll see that the slightest difference is going to change the whole problem. Okay, now for number 16 and number 17 here, what we're going to do is try to complete the square, because right now I have x squared plus 4x plus 13 and t squared minus 2t plus 2. If I were to complete the square, I'm going to have x plus 2 squared plus 9 dx, and this right here looks like inverse tangent, because it is. So my a value is going to be 3, and then my u value is going to be x plus 2. Now du right here is just going to be 1. So then if I were to do my little thing right here, I'm just going to be 1 over 3 inverse tangent of u over a, so u is x plus 2, a is 3, plus c. Alright, so for number 17, we're doing the same thing. We have the integral of 1 over t minus 1 squared plus 1 dt. Your a value is going to be 1. Your u is going to be t minus 1. And then your du is going to be 1 dt. So then I have the integral of 1 over u squared plus a squared. We know that's going to be inverse tangent, so I have 1 over 1. Inverse tangent of t minus 1 over 1 plus c. So inverse tangent of t minus 1 plus c. Alright, I am leaving 14 and 15 up to you guys. 14 is going to be inverse tangent, and then 15 is going to be inverse secant. And then just do more practice on this using your homework.